Lake Jessup is not just a lake. It is a living record of water, rainfall, and change in Central Florida. This high-powered simulation begins by placing Lake Jessup within the St. Johns River system, then peels back the surface to reveal the lake's bathymetry and the watershed that drives it. And then, everything comes alive. More than 11,000 days of daily water level fluctuation animate across the screen, transforming raw data into a visual time capsule of Central Florida rainfall since 1994. As one of the larger lakes in the Orlando area, Lake Jessup is deeply connected to the St. Johns River and its neighboring lakes. These simulations reveal those connections in dramatic detail, while also exposing the high-resolution contours and hidden shape of the lake bottom. This animation shows the elevation data on a 1-meter grid for the terrain and the underwater part of Lake Jessup and its surface water runoff watershed. The elevation datum shown is in the NAVD 1988 datum. Elevations are as low as -9 and as high at positive 124 feet at Baldwin Park. The scripts to generate these high-precision graphics were written in Earth Engine, which is able to handle massive data sets. Colors are painted on a dark map so they pop out on the screen, and then the final animation uses the satellite image for orientation. There have been modifications to this basin, and Howell Creek is a known overloaded system. The 100-year flood elevation of Lake Jessup is close to elevation 9 feet. This mark was met for the Hurricane Ian flooding. The lake dries up to elevation -1 to -2 feet, which is at sea level or below. It is a shallow lake with not significant groundwater flux as the Butler chain of lakes in Windermere. Development is moving into the fringes of the shoreline, so this data is informational for engineers. The Lake Jessup watershed covers both Orange and Seminole counties, with the Winter Park and Orlando area being added into the Howell Creek system, Erie in the development of Orlando. This review on Google Earth shows that the basin is built out, and it is radically different than the land cover in 1890 when the first Orange County survey map was prepared. It is a very complicated drainage system which introduces stormwater flows into natural systems which were not formed to handle such high urban flow rates. And the shallowness of the lake also creates water quality issues. This may be one of the most powerful pieces of water-level scripting ever created in Central Florida. Part 1 begins by stripping away the surface and revealing the full bathymetry of Lake Jessup, from -9 feet in the bottom of the basin to +9 feet at flood elevation. It is the foundation of everything that follows: the shape of the lake, the storage of water, and the geometry that drives its response to rainfall and flood conditions. What would normally take decades to experience in real time is compressed into a powerful visual sequence, allowing you to relive some of Central Florida's most significant rainfall events in just moments. Major wet periods, sudden surges, and extended declines begin to appear with remarkable clarity. The animation does more than show changing lake levels. It reveals how Lake Jessup responds to rainfall, runoff, storage, and recovery across thousands of days. Each movement in the hydrograph reflects real hydrologic events that shape the lake over time. As the chart advances and the water surface changes, you are watching a living record of Central Florida rainfall history unfold before your eyes. After the narration concludes, the simulation continues to play to music, giving you a chance to absorb the full visual power of the model without interruption. In that sequence, data becomes motion, and motion becomes memory. The result is both a scientific visualization and a cinematic time capsule of water moving through one of Central Florida's most important lake systems.